Hi and welcome to Study Hacks. So today, first of all, I also try to show you that an announcement. So here you can see this is our total 7 days online private training program on Google Earth Engine for remote sensing analysis for beginners to advanced level. So basically in this course you can join with me alone and learn all of the course content, and I also focus only for the beginners who don't have any programming language and who don't have any knowledge about the Earth Engine platform. So I hope after completing this total 7 days training you are able to learn all of the Google Earth Engine code easily, and you can easily do any remote sensing analysis. And in this course I also focus all of the beginners part, then I will move to the advanced part of Google Earth Engine platform. Okay, and this is the total 7 days course content, and each day I will provide you the total 3 hours online training session. If you want to join this online training, you can just contact with me this WhatsApp number, as well as you can also contact with me this email. Thank you.
Hello, sir.
Hello, can you hear me? Hello, can you hear me?
Yes, sir, I can hear you.
Okay. Can you see my screen now? Yeah.
Yes, sir. I joined from mobile. I'm trying to join my from laptop also because in laptop it was showing updating.
Okay, no problem. Actually, when you want to join the two device, then we can after completing the 30 minute, then I also send you the again Zoom link. Actually, it's the
Okay.
break when the one or two person or more than two person will be joined within a Zoom. This meeting session will be
Okay.
end after 30 minutes. Then I also send you the Zoom link. Then you can also join. Okay.
Okay. So should I leave from here and
Yeah.
log into laptop?
Yeah.
Okay, sir.
It's better. I think it's better.
Yeah.
Okay.
Yes, sir. I have joined.
Okay. Okay. So can you see my screen now? Yeah.
Yes, sir.
Okay. 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 So hi and welcome to the 7 days online training session on Google Earth Engine from beginners to advanced level. So we already covered some classes. So today I am course coordinator in here, and this is our full course content, total 7 days course content. I also try to complete all of this part step by step, so that you can easily understand all of the things. And basically today this is our other course for advanced course on Google Earth for the land cover classification. And previous class we also tried to cover the some part of the land cover classification. So I also try to, in this time I also try to more advanced focus on land cover classification map, how you can easily calculating the area for the big region. Okay, so all of the part we can cover in this here. And previous class I also try to show you that previous class we also try to complete this part for making the land cover classification, how we can easily make the land cover classification using the different types of machine learning method. Suppose we can use here the random forest, we can use the classification and regression trees, we can use the minimum distance, all of the classifier we can try to use here. And also check here the accuracy assessment. What is the accuracy? It means that what's the model is the good or bad. Okay, So you can also calculate the area. We can also calculate the area for each feature. Here you can see we can calculate the area for build up, a water body, all of that we can calculate the area, classified area. We also show you that how you can easily add the legend. All of the part we cover. Okay, so basically you can see when I calculated the area for the small region, I can easily make the chart like this. Okay, when you want to make the calculated the area and make the chart for the small region, but when you want to make the land cover classification map for the whole country, suppose I want to make the land cover classification map for the whole country of India or Bangladesh, okay, then I also want to calculate the area. But in this time it's not possible. When you want to calculate the area as a chart like this for a big region, it's not possible. Okay, so then we also need to apply the another method for calculating the area. Today I also try to show you that. Okay, so first of all I simply open a new code editor in here. I open a code editor in here, and in this time I simply use make the land cover classification map for my whole country boundary of Bangladesh. Then I also try to show you that how you can easily calculate the area for every individual feature in Bangladesh country. Okay, so I go to my slide. So in this time, first of all you can see calculating the land cover classification area. Mainly we can also calculate the vector area in Google Earth Engine platform. Also we can calculate the classified image area. Suppose how many build up area or how many water body, how many cropland will be available in your area. It's called the image area. We can easily calculate this image area per pixel area. We can easily calculate this. And also you can see vector. Suppose you can see this is the country boundary of Bangladesh. This is the vector part. I also try to show you that. Suppose in this time I simply import the vector layer in here. Here I already show you that how we can easily import the vector data in here. So here I already imported my vector data in here. So I simply import this vector layer in here. So I simply open my country boundary shapefile of Bangladesh in here. So I can see this is the shapefile of Bangladesh. I want to calculate the total area of Bangladesh, and this is the vector area. Okay, so this is the vector, not raster image. I want to calculate the area. Okay, so it's also possible in Google Earth Engine platform as a how you can easily calculate the vector area. So first of all I simply import my region. You can see it will be imported, and I simply put the name is that Bangladesh. Okay, you can use any variable name. Okay, so now I want to show the layer. In here my object name is that Bangladesh, and then I simply remove all of the part. It's not needed for this time. And then I also want to focusing the center of the shapefile. I simply use here the map center object, this function, and in this time you can see my object name is the Bangladesh. I simply put here the Bangladesh, and I also add here the zoom level. I simply put here the zoom level is the 10, and on complete, not needed for this time, I simply remove it. Okay, then click to the run. So now we can see here this is my area of country boundary shapefile of Bangladesh, and now I want to calculate the area. Okay, so what's the area of Bangladesh? I want to calculate it. Okay, so it's called the vector area. Okay, you can see in this time I want to calculate the vector area. So when you want to calculate the vector area and raster image area, it's totally different. Okay, so we can use here the totally different function for calculating the two area. First area is the vector. This is the vector data. You can see here I imported my shapefile, and second this is the classified image area. Okay, so when you want to calculate the vector area, I simply put a variable in here. And give the variable name is the Bangladesh area. Okay, you can use any variable name. After this, in this time I simply call my this object name Bangladesh, because I want to calculate this area, and this area, this shapefile area is stored in a variable. This variable name is that Bangladesh. I simply call the Bangladesh and paste here. After this I need to define it's my geometry. I need to define it's my geometry area or geometric area. So that's why I simply use here the geometry function, geometry. Okay, then I want to calculate it the area. I simply use here the area function. Okay, now I want to print this, so I simply use here the print, then call my Bangladesh area. Okay, then paste here, then click to the run. So now it will be provide me this area as a meter. Okay, a square meter. I can get the result. You can see this is the total square meter. So area of Bangladesh. Okay, I want to get the area of the square meter. So now I want to convert this area as a square kilometer. So I can easily convert it. So I simply take a variable and give the variable name is the Bangladesh area square kilometer. Okay, you can use any variable name. So in this time I simply normally I put here the variable name Bangladesh area square kilometer. So in this time you can see this is the value and in this time this value is showing the result as a square meter. In this time I want to convert it a square kilometer. So I can simply divide this value. This is my number. I simply divide this number with 1 million, so that it will be automatically convert from a square meter to a square kilometer. So I simply divided with this value, this number I just divided 1 million. Okay, and you can see this number is stored in a variable. This number is stored in a variable. This variable name is that Bangladesh area. I simply call the Bangladesh area and paste here, and this is the number. Okay, so this is the number. So that's why you need to use here the earth engine number function, because this is stored in a number. So I simply use here the ee dot number, and then I simply use here the divide function. I divide with 1 million. 1 million is that this is a scientific notation. 1 million is that 1e6. Okay, so now it will be convert the result as a square kilometer. I want to check it. I simply use here the print function and then simply call the Bangladesh area square kilometer and paste here. Okay, then click to the run. So now in this time I will get the result of Bangladesh area in a square kilometer. Okay, you can see I can get the result, the square kilometer 1,39,703.99 something square kilometer. I can get the result. In this time I want to get the only for the integer value. I ignore all of the floating value. So that's why I can simply use here the round function. I simply use a function, this function called the round function. So round is a function. For when you use the round function, it provide you only for the integer value. Okay, so I simply run this code. You can get the result. You can see now we can get the result as a round figure. You can see only for the 1,39,704 square kilometer. Okay, so you can see using this procedure, we can easily calculate it any vector area. Any vector area you can easily calculate it. First of all, you can simply import your vector area. Then you can define this is your geometry. Then you can simply use here the area function. Now it will be calculated the area in a square meter. I want to also return this result as a square kilometer. I want to get this result as a square kilometer. So that's why I simply use here this divided with the 1 million. Okay, then I also need the round figure, so I simply use here the round function. Then I can get this result 1,39,704 square kilometer, the country boundary of Bangladesh. Okay, so I hope you can understand this topic. Any question in here or any doubt?
No, sir.
Okay, we can easily calculate the any vector area using this method, no problem. So now in this time, suppose I want to make the land cover classification map for the whole country boundary of Bangladesh. You can see this is the country boundary shapefile of Bangladesh, and I want to add here the land cover classification map, and then I also want to calculate the area for the whole country boundary shapefile of Bangladesh. So for this I simply use here the, in this time I use here the MODIS satellite data. Okay, so I simply use here the MODIS satellite data. So I simply search here MODIS land cover. Okay, I browse the data catalog. And then simply go to the MODIS. In this time I want to use here the MODIS land cover data set. So I simply click the MODIS.
Recording in progress.
So I simply use here the MODIS data set. So I simply click on the MODIS. So I found the MODIS dataset for the land cover classification. Okay, so you can see this is the MODIS land cover yearly global 250 meter resolution dataset. So we can easily get the dataset between this time period. Okay, and also you can see this is the dataset provider, Earth Engine Cinepet. This resolution is the 500 meter. Also you can see some the band of this dataset LC type 1. So LC type 1, this is the annual international geosphere and biosphere classification. Okay, we can easily get this annual international geosphere and biosphere program classification for the whole world. We can easily get from here. Also you can see LC type 1, it's also some value, and respected value provide you the description. You can see we can easily get all of the feature, total 17 feature we can easily access using the LC type 1 band. Okay, so in this time I want to simply use this satellite imagery and make the land cover classification map for my whole area country boundary of Bangladesh, and then I also want to calculate the area. So I simply copy this collection snippet from here. I simply copy and then I simply paste here. Okay, after this I simply provide a variable name. I simply take the variable name is the MODIS land cover. Okay, I simply put here the MODIS land cover. It will be imported in my code editor, and in this time I want to filter this MODIS dataset. Here you can see this dataset provided this time period. I want to need the dataset only for the year of 2019. So I simply filter this. So I simply take a variable and give the variable name is the filter it, and then I simply call the MODIS land cover. Then I simply use a function. This function called the filter. How I can filter? In this time I want to filter here the date. I simply use here the e-filter dot date. Then I simply put here the date function is that I can simply put here the year of 2019, 1st January to 2019 December 31. I can simply put the date, and between this date I want to get the first images. So I simply take a variable and give the variable name is that land cover 2019. I simply use the variable name, and then I simply use here the ee dot image dot then I simply call here the filter it, this variable, and then I simply take here the first image. I simply use here the first. Okay, and in this time here you can see I select this, and now I also need to select the specific band, okay, of the first images. So I simply use here the classified. You can use any variable name. I simply use here the classified, and then simply call the land cover 2019. I simply call him, and then in this time I simply use here the select function. Okay, and then in this time I simply put here my band name. Here you can see my band name is the LC type 1. I simply copy and paste here. Okay, so now it selected the band of like LC type 1, this band, and under this band you can see all of the classes. Under this LC type 1 we can see all of the classes. Okay, total 17 classes. Okay, so I simply select this band. In this time I want to show the result. I simply use here the map dot add layer, and then I simply call the classified. Okay, and I also add here the visualization parameter is that I simply use make a dictionary, and here I put here the mean 1 and max 17. Here you can see this class, the mean value it will be start from the 1 and max 17. Okay, I simply put here the 1 and 17, this range. Okay, and I also want to add here the color plated. I simply use here the plated, and then I simply use here I plated as a dictionary. I put all of the color, so I can simply get all of the color in here. So I simply copy the color plated from here. So I simply copy. Okay, and then I simply paste here. Okay, and you can see, and then I simply use here this as a layer name. I simply put here the layer name is the Moody's LULC 2019. Then click to the run. So now I can get the land cover classification map for the whole world. You can see I can get the result for the whole world. You can see we can get the result for the whole world, for the whole land cover classification map year of 2019 using the Moody's satellite imagery. Okay, we can get this data. Okay, so you can see this is our land cover classification map, but in this time I want to need only for my country Bangladesh for the land cover classification map. So I can easily clip with this region. Okay, so here you can see, here I already imported my shape file Bangladesh. Okay, it will be imported in here. So now in this time I just use here the clip function. So for this I simply take a variable and give the variable name is that, I can simply put the variable name is that Bangladesh LULC. Okay, I can simply put here the Bangladesh LULC, and then I simply call this classified image because it covered the whole world. In this time I want to need only for my region of interest Bangladesh. I simply use here the clip function. It will be clipping with this variable Bangladesh. I simply call the Bangladesh and paste here. Okay, then I also want to show the layer, so I simply put here the I just simply copy this. Okay, I just simply copy and paste here. After that I just simply copy the Bangladesh LULC because in this time I want to show the layer, and just paste here. Okay, then click to the run. So now it provided only for the, you can see there is the two layer. I also put here the Moody's LULC. I can simply put here the Bangladesh. So this is the, you can see layer name. So here I add here the first layer is that Bangladesh Moody's LULC year of 2019, then Moody's LULC 2019 for the whole country. Okay, so in this time I want to work only for the Bangladesh. Okay, so I can simply just commenting this line, control and forward slash, then click to the run. So now I can see only for the one layer Bangladesh Moody's LULC. And now I want to calculate the area of the each feature, how many build up area, how many water body, how many forest, how many shrubland, how many cropland. I want to calculate it, and you can see this is the big region. Okay, if you want to make the chart like this, you want to make the chart like this and calculate the area, it's not possible in here, because there the lot of pixel value will be available in here. Okay, there the lot of pixel value will be available in here, so that's why it's not possible. So in this time we can use here the another methodology or another technique for making the calculating the area for each feature. Okay, okay, can you hear me?
Yes, sir.
Okay, so if you have any if you don't any understand anything, don't understand, then let me know. Okay, so I will also try to explain.
Sure.
Okay,
Sure.
okay, so in this time I want to just calculate the area of the each feature, how many all of the area is available here. I want to calculate it. So first of all I will try to discuss about the single class. Here you can see there are a lot of class, but in this time I want to need only for the build up area. Okay, I want to need only for the build up area. In this time I want to in this map you can see there are the lot of classified area will be available here. In this time I want to only show them on this map only for the build up area. Then I also want to calculate the how many build up area will be available here. I also want to calculate it. So it's also possible. So first of all I simply use here I can simply use a variable name. So I can simply take the variable and give the variable name is that urban, okay, or urban area, anything. I can simply call the urban. Okay, so in this time you can see this is my Bangladesh LULC. In this time I add here the Bangladesh land cover classification map, and in from the map I want to use only for the build up area. I want to need only for the build up area. Okay, so that's why I simply copy the Bangladesh LULC. Then in this time in here I just use here the equal. I can simply use here the equal. So what's the value of build up area or urban area? I can simply use here. You can see they are already provided the build up area value. So I can simply go to here. You can see they are already provided the urban or build up lands. This value is the 13. This value is the 13. I can simply use here the 13. Okay, I simply put here this value is that 13. Okay, so now I want to show the map only for the urban area. So for this I simply take here the map dot add layer. Okay, then use here the urban. Okay, in this time I want to show the urban. So for this I can simply use here the dictionary and use here the mean. This result is a 0 and max is result is that 1, and then I can also use here the plated function, plated, and in this plated I simply use here the gray and use here the red. Okay, it means that you can see red. So in this time here you can see what I can happen. First of all I can simply select my class, urban class or built up class 13. It is stored in a variable urban. Then I simply use here the urban. I use here the mean 0 and max 1. Mean 0, it means that there is the no urban, and it's showing the color as the gray. Okay, and also you can see here when I use here the 1, it means that there is the urban area or built up area. It's showing as a red color. Okay, I can simply run this code. I can simply run this code. Here you can see. Now it will be provide you the only for the urban map of the country boundary of Bangladesh. Sometime you also need only for the crop map. Sometime you also need here the only for the water body map. Sometime you also need for here the urban map or built up area map. So here you can see this is our total build up or urban area in Bangladesh, only for the red color. And where you can see the gray color, there is the no urban. We can also say that this is our urban map of Bangladesh. Okay, so you can see this is our urban map of Bangladesh. We can create this map. Okay, we can easily export this map as a TIFF format and work with the ArcMap or QGIS software for representing the urban map of Bangladesh. Okay, so you can see this is the urban map. We can get here the single image, only for the single image for the urban. We can easily identify the urban area. And in this time I want to calculate the urban area. And you can see this is the image or pixel value. When you want to calculate the pixel value, you need to use a function, this function called the image.pixel area. Okay, so I can simply take a variable and give the variable name is that area image. Okay, I can simply use here the area image, and then I simply call here the urban, and then in this time I simply use a function, this function called the image.pixel. So in this time you can see this function, I can simply multiply with this function. Multiply, my function is that ee.image.pixel area. Okay, so this is my function, and this image.pixel area, this function get you this result as a square kilometer. Okay, I also check this, I think this is the square meter. I can simply copy the function variable name and go to the docs tab and then paste here. Here I can get all of the information. You can see this pixel area, that pixel in square meter, we can get the pixel area in square meter, this unit. Okay, when I calculated the area, in this time I want to calculate the urban area, so that's why I simply use here the urban. This urban area, it will multiply with this function, and now I want to calculate the area. So first of all I simply use a variable and give the variable name is the area. Okay, and then I simply call the area image, and then I simply use a function, it's called the reduce region. Reduce region is a function, it calculated a specific boundary or area, a specific statistical function. Suppose if you want, you can calculate the area for how many built up area will be available here, or we can also calculate the mean NDVI or max NDVI, all of the things in a specific region. So reduced region is a function, it's calculated the any specific region with the different types of statistical parameter, mean, max, sum, all of the things it calculated easily. So in this time I want to calculate the total pixel value of urban, how many pixel value in available in my urban area. So that's why I simply use here the reduce region. Okay, and then I simply use here the, you can see you can get all of the argument. What's the argument of the reduced region? I can simply make a dictionary in here, and I simply put all of the things. First of all, reducer. So reducer is a function. In this time I want to calculate the total pixel value. Okay, not average or not mean or not max, I want to calculate the total. So I simply use here the reducer dot sum. Okay, this is my function, it calculated the total pixel area. Okay, then geometry is that in this time my shapefile variable name, here you can see my shapefile variable name is the Bangladesh. I simply copy the Bangladesh and then I simply paste here, and then I define it. This is my geometry, I simply use here the geometry. Okay, then scale, scale is the resolution of your satellite imagery. In this time this is the 500 meter. CRS not need, I simply remove max pixel is need. So max pixel is that, I can simply put here this max pixel is that 1E10. Okay, tile I simply remove it. I simply print this and then I simply call the area and paste here. and in this time we can get the area as a square meter. You can see it will be calculated the only for the urban area, how many urban will be available in here for the Bangladesh. We can for the year of 2019 we can get here the total urban area, you can see, and in this time this area is that square meter. Okay, I want to convert it square kilometer easily, so I in this time I also calculated the square kilometer. So for this I simply use a variable and give the variable name is the urban area square kilometer. Okay, then I simply use here the EE dot number, and what's the number? This is the area number. I simply copy the area and paste here, and then I simply use here the divided with the 1 million. I simply use here the divide 1E6. Okay, scientific notation. Then I can simply print this urban area. Simply copy and paste here, then click to the run. So now you can see it provide you this result. Okay, in this time it also showing the error. In this time where I can get the result of the urban result, where I can get, in this time I can get the result area, and this area I can get this result from a band. My band name is that LC type 1. You can see I simply copy the LC type 1, this band name, and paste here. Okay, then click to the run. So now it will be appeared, you can see. Okay, this is my urban area. Okay, in square kilometer. Okay, you can simply use here this round function only for take the integer value. Okay, so now you can see it will be provided this result 1096 square kilometer. Okay, and in this time you can see I can just calculate it only for the single image. Okay, and then I also try to show you that how you can easily calculate all of the class, not only for the urban, how we can easily together we can easily calculate the build up area, urban, water body, everything, all of the class set images. So this is the process only for the single image. So single image means that only for the urban, only for the water body, just you can change here the value. Okay, and in this time I want to, you can see this is our previous task for making the land cover classification map for the Dhaka city. In this time I want to also add this code, and I want to calculate it only for the single image. So I want to calculate it here the single class area. Okay, in this time I want to use here the same code. You can see this is my code. I simply copy this code from here. Okay, and then I simply paste here. In this time in here I just simply change something. First of all, in this time Bangladesh LULC, instead of this variable name I just put here this classified variable name. In this time here you can see my classified variable name is that, here I use the classified variable name as a classified. I simply copy the classified variable name and then just paste here, okay, and I also need to select here the value. What's the value where I can get the value? When I import by the build up area, you can see I put a value is 1, so I simply put here the 1. Okay, 1, and now I want to show the result. You can see urban, I can use here the only for the, you can see red color showing only for the build up area, and other all of the class will be as a gray color, so I use here the gray color, and it's my urban area. I also want to calculate the is a single class area. So in this time here you can see all of the things will be same, just I simply use here the resolution. In here I use the satellite imagery, so that's why I simply use here the 30 meter resolution. Okay, and then I also need to use here the change the variable name. You can see Bangladesh, I can use here the my ROI is that ROI, so I simply use here the ROI. So this is my ROI. Okay, then geometry, and then in this time you can see get LC type 1. In this time I want to get the result from here. You can see this is the class. Okay, I simply copy the class and then simply paste here, then click to the run, so you can see what's happened. Okay, so I think this is the classification. Okay, okay, so now it okay, you can see we can get this result. This is our value. This value is that you can see we can get the value in a square kilometer result, not hectare. It is the square kilometer. And also you can see this is your urban map. So you can see this is the urban map for Dhaka city. We can get the only for the single image map, as well as also calculate the single image area. You can see it will be showing only for the red pixel value, only for showing here the built up area or urban area, and other where you can see the gray color, it means that there is the no built up area. Okay, so this is the map for urban map of Dhaka city. We can easily export this map and work with ArcMap software easily. And also you can see we can calculate the single image area, how many urban area in available in here. So in this time we can calculate the area where we can get the total area 156 square kilometer. Okay, so I hope you can understand. Any question in this time in here? Any question or any doubt? Hello, can you hear me?
Yes, sir.
Any question or any doubt in here?
No, sir.
Okay, and I also send you all of the code, as well as also send you the video, so that you can also practice more 2 or 3 times. I hope then you can easily understand all of the things, no problem. And after 1 minute this meeting will be end, then I also send you the Zoom link again, because first of all you can join the 2 device with this link, so that's why it will be break after 30 minutes. And after this completing this, I will send you the Zoom link again, so that you can also join with us. Okay, and and then we also calculated the all of the classes, how we can easily calculate all of the classes together. Okay, and I also give an announcement in here. So anyone, if you want to join our online training on 7 days online training program on Google Earth Engine from beginners to advanced, so you can easily join with us and learn all of the course content. So basically in this time we can focus only for the beginners who don't have any programming language or any Google Earth Engine knowledge. Okay, I hope after completing this the total 7 days course, you are able to do any remote sensing analysis using this platform. Okay, so here you can see this is our course content, and you can easily join our course anytime. Actually this is our private training program, so you can easily join anytime. Okay, so you can just contact with me this WhatsApp number, as well as also contact with this email. Okay, so then you can easily make the registration and you can join anytime. Okay, because this is our totally private training program, and this is the total 7 days, and each day 3 hours live training session. Okay, so thank you.